So in today's lesson we're going to be looking at putting our definite integrals to work, an application of integration. But by way of introducing the topic, why don't you have a go at these two starter questions. The first one, I want you to find the area under the shaded area that's given. Basically just split it into a rectangle and a triangle and see if you can find the area. And on the second one, just a reminder of our definite integrals, see if you can evaluate that definite integral. Pause the video at this point, answers coming up in a second. Okay, so solutions to the starters. First one, trickiest bit was probably we needed the heights for our rectangle and triangle. We can get that by substituting the x value in. We get the two y values at the appropriate points. We can then use that to break the shape down. We should have got the rectangle to be 14, we should have got the triangle to be 4, and that gives me a total area of 18. And the next question, to evaluate the integral, do your integration, substitute the upper and lower limits in, and you find the value of that is also 18. And that's the important thing. That's the connection that I was hoping you've maybe made as you work through that. You should have noticed that the graph in question 1 was exactly the same function I asked you to integrate in question 2, and the area in question 1 was between an x value of 1 and 3, and in question 2 those were your upper and lower limits. And that's today's big connection, the connection between a definite integral being used to work out the area under a curve. So now that we've hopefully got today's big connection, here is the note that would be, you can pause the video and copy this up. So basically today we're looking at the area under curves, and the starter was designed to try and show you that how we find the area under a curve is we make use of the definite integral. You don't need to know why this works, but I will provide the assignment I'll leave you on Teams. If you so wish, you can go away and follow that link and delve a bit further into the maths. But for our purposes, you just need to know you can find the area under a curve by making use of the definite integral. The example we did in the starter there, the area was above the curve, so that all works fine. There are a couple of other examples that you need to be aware of. They are given in the note here, so why don't you copy up the note, pause the video to do that, and then I will follow up with a couple of examples showing the other two situations that you can get. Okay, so we'll have a look at an example here of the second type of problem mentioned in the note there, where our area is under the curve, or under the x-axis. So you'll see in the diagram here, we've got our function and we've got our area given, and it sits under the x-axis. So what I'm expecting here is I'm going to evaluate my definite integral, but I expect to get a negative answer. We don't worry about that, we'll just deal with that at the end. So we know that this area here is given by the definite integral of the function. So our function is x bracket x minus 3, and I'm going to integrate that, and I want to integrate it between the limits of my area. But we'll see here, rather annoyingly, I don't actually know what these 2 points are. I haven't been given them, I haven't been given my limits. But that's not a problem, because I know they're on the x-axis. I'll be able to find them. They're basically the roots of the function. So we reminder how to find the roots of these functions on the x-axis. I want to set y equal to 0. So I'll just quickly do that up here. I'm going to set y equal to 0 and solve for x. So two numbers multiplying to make 0. I know that either or has to be 0. So either I've got x equal to 0 there, or I've got x equal to 3 there, just making that bracket equal to 0. So I know that this point here is 0. I could probably see that from the diagram, but we've got to check it mathematically. And then this point is 3. So I've now got my lower limit of 0, my upper limit of 3. So now I can just go ahead and evaluate this definite integral. So probably need to prep this first before I can integrate it. So we're going to get x squared minus 3x. I can now go ahead and integrate. So remember, for definite integrals, we show our square brackets and we move our limits to the end. Integrating x squared gives me x cubed over 3, and then for the 3x squared, I'm going to raise the power by 1 and divide by that new power there. So that's it, integrated. Now I just need to put my upper and lower limit in. So first of all, let's put 3 in as the upper limit. And I'm going to take away from that the lower limit of 0 when I put that in. So you can probably see already, you've got to just be a wee bit careful sometimes putting 0 in, that you don't automatically think, oh, it'll always give a result of 0. But in this case, I know that this second bracket is going to give me 0, but we'll just go ahead and evaluate them. So I'll just move up here because I'm running out of space. So what we get then for this first bracket, the first term is 9, and I evaluate the second term there and I get 27 halves. Again, double check that for yourself, minus the second bracket of 0. So I really just need to calculate this first bracket here, don't need to worry about the 0. And when I calculate that, okay, what we end up getting is we get negative 9 over 2. Just in my head made that 18 over 2, and I get that. So I've got negative 9 halves as the value of this definite integral, but we were asked for the shaded area. So what we have to say then is we have to say that we know it was a negative answer because it was under the x-axis, so my area will be 9 over 2, and that'll be some units squared. Don't know what my units are, don't know if they're centimetres, but we get that. And a nice thing might be just to say here, you know, as under x-axis, so we explain why we know we got a negative answer. So that's how we deal with an example where the area lies under the x-axis. So we'll now have a look at an example where we have an area, but part of the area lies below the curve and part of the area lies above it. So from the note, we know we're going to treat this as two separate areas. So we'll maybe call this one here A1, and we can call this one A2, and we can just evaluate between the limits. But again, I know area 1 starts with a lower limit of 0. I'm interested what this upper limit here is for area 1. So again, like the last example, how do I find this root of the function, as it were, or where it crosses the x-axis? Well, I set y equal to 0. So I'm going to do that to find the point. So we can say here, when y equals 0, then we can get x equal to 4. So I know that this point now is the point 4. So area 1 then is represented by the definite integral from 0 to 4 of the function which is x minus 4. And then area 2 is going to be represented by the definite integral of the same function, but this time this area has a lower limit of 4, upper limit of 7. So we've got a lower limit of 4 and upper limit of 7 there. And now I'm just going to go ahead and evaluate both these integrals, definite integrals. I'll get two separate areas, then I can add them at the end. So have a look at A1. Now we know this area lies under the curve. I'm expecting a negative answer, but then we can just change that to positive because we obviously can't get a negative value for an area. So we can go ahead and we can evaluate this. So we do our integration. It's going to be x squared over 2 minus 4x, and then the limits can go in. So an upper limit of 4 gives me 4 squared over 2 minus 4 lots of 4, and I'm going to subtract from that 0 squared over 2 minus 4 lots of 0. This first term gives me 8 minus 16, and I'm going to take away from that, quick check, this does make 0 here, so I get an answer of negative 8, but we know that for the area that's going to be 8 units squared. So that's what that represents there. So just evaluate my definite integral, got a negative answer because it lies under the x-axis, can change it to positive for the area. So we'll now go over here, we'll do this one. Obviously the integration is going to give me the exact same thing because I'm integrating the same function. All that's different is different limits are going in. So my upper limit that's going in this time is 7 squared over 2 minus 4 lots of 7, and we're going to take away from that 4 squared over 2 minus 4 lots of 4. Can evaluate this first bracket here, we end up getting 49 over 2 minus 28. And this second bracket, we've actually already done this over here. We've already put this upper, or this limit of 4 into it, so that we know that this bracket here is going to give us a negative 8. So going ahead and work this out, and we end up getting an answer of 9 over 2. Okay, and that's positive value because this area lies above the curve. So area 2 is 9 over 2 units squared. So I've got my two separate areas. Now all I need to do, add the two of them together. Again, running out of space, so we'll just go up here. Total area equals A1 plus A2, which equals 8 plus 9 over 2. Final answer 25 over 2. And because we're working with area, let's just get into the habit. Units squared. Okay, so that's how we deal with the different types of questions we might face for areas under curves. If you haven't already, I would be pausing the video, copying up these worked examples into your notes jotter, and then the questions that you can do in the textbook will follow shortly on the video. So if you've been able to follow this video along, then you should be able to do the following questions in the textbook. I've just picked out 9 questions there for you to do. So have a go at working through them. Again, you don't need to do them all. It would be great if you could, but all you should be spending each lesson is an hour on these activities. So hopefully between the video and these questions should give you about an hour's worth of work. If you don't get it all done, don't panic. If you get it finished in half an hour and you're looking for some more, then by all means pick a few more questions from the textbook if you wish. Okay, so as always, have a go at these questions, get in touch if you need any more help, and we can support you through Teams or with some further examples.